All right, welcome back, ECA students. We're going to start part 2, vocabulary and concepts for solutions. Oops. All right, when it comes to solutions, we can't not talk about water. Water is the best solvent out there, and it actually has a nickname called the universal solvent because water molecules have a unique structure that allow them to be polar and have hydrogen bonds, and this makes them able to dissolve more substances than any other solvent out there. We use water as a solvent daily to wash our clothes or to make our favorite drinks, aka coffee or tea. A solution where the solvent is water has a special name, and that's called an aqueous solution. If you ever see a chemical reactions where the phases are listed in little parentheses next to the molecule, such as G for gas, you may see AQ, which stands for aqueous solution. All right. Well, what does dissolving actually mean? We describe dissolving as a tug of war between forces. Forces are not going away. Attraction or force of a water molecule to ions is actually called hydration force. So that attraction, the hydration force, is an attraction between an ion on the surface of a crystal and on a water molecule Water can dissolve table salt because the hydration force is greater than the ionic bond force that holds the Na and Cl together, because polar water molecules are able to exert a force on the ions by pulling them away. A molecule is ionized when it has been dissociated into ions, positive and negative cations and anions, when dissolved in a solution. So that's an important vocab word, ionization. When ionization occurs, free ions exist in solutions. We call these free ions electrolytes. Electrolytes are incredibly cool because when they exist in a solution, that solution can conduct electricity. This is how battery acid works, and also how our neurons work. We've heard that electrolytes are good for us, and that's why Gatorade is so wonderful. We actually need electrolytes because they are what is able to conduct electricity in our neurons. When we send a signal to our brain sends a signal to our muscles. When we send a signal to our brain, or our brain sends a signal to our muscles, we create something called an action potential that acts like a big wave through our neurons. Our neurons use the electrolytes by pushing them across membranes to create that electric current. Pretty cool. All right, concentration and dilution. We've heard these words before, like how I don't think I can concentrate on this slideshow lecture much longer. Just kidding. Concentration is just the ratio of a solute to the total solution or to the solvent. More often than not, it's the ratio of the solute to the solution. We can look at a salty lake and say that the salt concentration is high in the lake compared to fresh water, where obviously the concentration of salt to the lake would be low. Say we want to make the lake less salty. We can do that by diluting the lake. The way we do that is by adding more solvent or water. A great example of concentration and dilution is juice concentrate. I don't know about you, but I grew up on these Minute Maid juice concentrates, where you would take the juice concentrate in the frozen can, and you would add it to a pitcher, and then you would add 3 cups from this container of water to dilute it, creating that lovely juice mix. Here are other great examples of diluted chemicals. So hydrogen peroxide and rubbing alcohol can actually be very dangerous chemicals when concentrated. So we have a solution by creating solutions. Get it? Here we see 3% hydrogen peroxide and 70% isopropyl alcohol, making them a little bit safer. What a great solution to the problem. All right. So I know how much you miss math in chemistry class, so I have some for you. Unfortunately, it's really easy math. Sorry. In chemistry, we use molarity to measure concentration. We simply do this by dividing the moles of solute by the volume of solution in moles per liter. So your equation is going to be molarity equals moles of solute divided by liters of solution. All right, so here's your equation. Capital M equals N divided by V. M equals molarity in moles per liter. N is the number of moles. Sorry, that should be a lowercase n. V is your volume, which is measured in liters. So please be careful. It's really easy to mix up moles and molarity. They're actually different things. The way I recommend doing these problems in your quiz is list all the givens and unknowns and then write out the equation. Let's do some practice problems. All right, so we're given a problem. A solution is made when 2.5 moles of sodium chloride is dissolved in 3 liters of solution. Let's calculate the molarity. So let's list all of our givens, unknowns, in our equation. We don't know M because we're solving for that. We do know N, which is 2.5 moles, and we do know volume, which is 3.0 liters. There's our equation. Let's fill out the equation. M equals 2.5 moles divided by 3 liters, which you punch that in the calculator and you'll get 0.83 molarity, moles per liter. All right, let's do a couple more. So we have 3 moles and 0.5 liters of solution. So M, we don't know. N is 3 moles. V is 500 milliliters. We're going to turn that into liters by converting units, and we get 0.5 liters. You just divide by 1,000. All right, let's use our equation. We got 3 moles divided by 0.5 liters, and our answer is 6 moles. 3 divided by 0, sorry, not moles. Woo! Molarity, moles per liter. See how easy it is to mix it up? 6 moles per liter of concentration. All right, let's try again. We have 232 grams of sodium chloride and 0.75 liters. This is where stoichiometry comes in handy. So we don't know our molarity. We don't know our moles. We're going to call 232 grams, but we need to convert that into moles. So we use our stoichiometry. And we know that the molar mass of sodium chloride is 58 grams per mole. We're going to cancel out our units and get 4.0 moles of sodium chloride. So now we know our moles. Our volume is 750 milliliters. We need to convert that to liters. So we will divide by 1,000 to get our liter units. We get 0.75 liters. We are going to set up our equation. Molarity equals number of moles divided by volume. We got 4.0 moles divided by 0.75 liters, and we get 5.3 moles per liter, molarity. All right, thank you for joining me. Good luck on your quiz. Please feel free to email me if you have any questions. And don't forget to like, comment, and subscribe. I'm just kidding. And if you do, I'm not giving you extra credit. All right, bye.